Next problem we will discuss search in rotated sorted array. Okay, problem is that we need to search an element. We need to search an element in a rotated sorted array. The problem statement is that there is an integer array nums sorted in ascending order with different values. Prior to being a passer to your function nums is possibly rotated at an unknown index, a pivot index, such that the resulting array is n of k2 and so on. Somewhere it will be rotated, like a previous example. For example, this might be the original array, but it might be rotated. The pivot index is 3. It becomes like a 4, 5, 6, 7, 0, 1, 2. Right? Given the array nums after the possible rotation on an integer target, return the index of your target if it is in nums, or -1 if it is not in nums. Okay. And also these people saying you must write an algorithm with log n runtime complexity. So yeah, this is also similar to like a previous example, previous problem, whatever we solved. But here we need to find the target. Depending on the target, we need to solve this problem. Probably there are two solutions we can think of. One is the brute force, and we just try to start from the index 0 and try to find the target. Whenever you find the target 0 and return that index. That is the O of n time complexity, but here we are expecting O of log n time complexity. For that, we need to use the binary search approach. That is actually we need to find the uh, we need to we try to eliminate the half of the numbers on each time when you are going to search for an target. Let us see these two approaches. We'll discuss and then we'll see how it works. Okay. Let us take example one. Example one is 4567012. Let me take input 4, 5, 6, 7, 0, 1, 2. I think and 3. 3 is there or not? I'm not sure. 0, 1, 2 only, right? Okay. So these are the input we have given, and the target is 0. Target is 0. So we need to return 0, 1, 2, 3, 4. 4 is the output. Fourth index is the output, right? So there are two solutions as we discussed. There is a first solution is the brute force. Brute force solution actually will take O of n time complexity because we have to iterate one time. So we'll start from 4, that is index 0, that is I is equal to 0. The value is 4. We'll compare the 4 and the 0 is not equal. Let's move on. I equal to 1, that is 5. 5 equal to 0, no. I equal to 2, this 6. 6 equal to 0, no. Then I equal to 3, that is 7. 7 equal to 0, no. I equal to 4, 0 equal to 0. Yes, we found the target. You can return this value. This value means index. That is what the problem statement is. Another solution what we are thinking is second solution could be uh, log n approach, right? Second solution will be like a binary search. Okay, a binary search. This time complexity will be O of log n. Okay, so this through this approach we will eliminate all of the numbers. Let's see how we can do that. So we can check it out left and right. We will initialize these two values from 0 and 1 2 3 4 5 6 7, that means 0 comma 6, that is n minus 1. Initially we'll do this and we'll try to check that L is less than or equal to right. Till that time we will iterate. This is actually like a infinite, I mean the loop, which actually if this condition is true it will keep running that. And in this case we'll try to find the mid number. Okay, in this case what will come, left is 0 plus 6 minus 0 by 2, that is equal to 3. Initially it will become 3. We'll see like this 3, first we'll check the nums of 3, that is 7. 7 is equal to target or not. No, this is not right. Then anyway we'll find the mid number is 3. Now we'll decide like left and right where we need to set this particular 3 depending on the comparisons. Okay, first what we will do is we'll see nums of left and nums of mid. Nums of left is currently 0, that is 4, and nums of mid is 7. Okay, if the case is that nums of mid is less than or equal to nums of mid, correct, that is 4 is less than or equal to 7. That if that is the case, what we will do is we will check that nums of like a num 4 is less than or equal to target or not. Target is 0. No, right? This is not the case. If this is failing, then what we will do is we'll move the left to mid plus 1. What is that? Left will become this one now. Left will become mid plus 1. That is actually 4. Okay. We are here now because of the conditions. Now again, what we will do is once we are done with this, then again iterate it. Now mid is 4. Sorry, mid we need to calculate. Left is 4 now. 4 plus and right is 6 minus 4 by divided by 2. That is equal to mid is equal to this one 2 by 2 1. That is mid is 5. Again we will calculate same thing. Left is equal to what? Left is 4 and mid is 5 and right is 6 currently. That's right, we are not changing. Now if you check it out, check that nums of left is nums of left. This is 0. 0 is less than or equal to mid value. What is the mid value here? 5 1. True. This is true, right? Once, okay, before this what we need to do is we need to check that we found the mid value, that is 5. Mid of uh, I mean mid value for 1 is equal to target. No, this is not target. That's why we came here. Now 0 is less than or equal to 1, and also we'll check that target is less than mid. Less than mid. Basically we got that we got this value, right? Now okay, left value, left less than or equal to mid, yes, true. Come here, left nums of left is less than or equal to target, and left and the target is less than or equal to mid. Target also less than mid. That is correct. Now in this case this will become, on right we will what make it is mid minus 1. What will become, right will become also 4, right? Left also 4 and right also 4. Now both will become 4. So now we will again iterate. Now what happened, this condition will fail. So left and right equal to same. Left and right equal to same. Oh, okay. L is less than or equal to R. So this is true. Again, it will come. We'll calculate mid now. Mid is mid equal to left is 4 plus 4 minus 4 by 2, that is 0. That is mid equal to 4. Now we'll check nums of mid, that is 4, equal to target. This is equal to target. Yes. Just return the mid from here. Okay. This is actually like a binary search approach. This will also actually takes uh, O of log and time complexity. Basically, we are trying to find the number using by avoiding the half of the elements by using the binary search approach. Let us write the code so that you will understand more clearly about how the binary search operation we are trying to do it. But first, initially, we'll try to do with brute force. After that, we will go for um, binary search approach. Okay, so what we will do is we'll try to use the for loop, which is I and num. We'll try to range of nums. We'll just try to see if num equal to target. That's it. Return I. Suppose you are not find any solution, any number, we will just return the -1. So this is the actually O of n time complexity. This is not the one we are expecting. Okay. Yeah, these test cases also will pass with this one. But this is very simple approach. We need to use the binary operation, binary search basically. Let us see that how we can write. Let it be returning -1 here. So binary approach could be like this. Okay, as I mentioned, the left and right we will initialize with 0 and length of nums -1. Okay. Okay, once we are initializing with these values, now what we will do, as I mentioned in the condition in the theoretical analysis, we'll write a for loop where left is less than or equal to R. We keep iterating this one. We'll try to calculate mid value, that is equal to left plus R minus left by 2. Once we find the mid value, we'll try to see if nums of mid equal to target. Just return the mid. Okay, otherwise what we can do is we'll try to see if nums of left is less than or equal to nums of mid. Okay, if this is the case, we need to check again if nums of left is less than or equal to target and target is less than nums of mid. So we need to see that nums of left less than or equal to target and target is less than nums of mid. In that case, what we can do is we can decrement the right to -1, else we can increment the left to mid +1. Okay, because we are already taking care of mid here. That's why we need to do -1 and +1, because definitely it is not a the mid value. Otherwise, what we need to do is, if that is not the case, then again if nums of mid is less than target and target is less than or equal to nums of right. Okay, in this case we need to see left, we need to left move to mid +1 and else right will be a mid minus 1. Okay, we'll come down one step. So we'll keep iterating this for loop. If you find that value as a target as a and mid value found it, that means we found a solution. Otherwise, no. Okay. So this is the big O of log n time complexity. Okay. Let me run this program. We'll see any issues with this. Okay. Else. Okay. I think that's fine. Let us run this one. Okay. That's it. This is also one of the good problem because people they will expect interviewer will expect this approach log and time complexity. This is basically to see how you can use the divide and conquer method to solve your problem. Okay. Thank you.